So throughout many of the lectures that are going to come, I will show you, let's say in practical terms, how we interact with deal.II and in many cases how we interact with some of the other computational science tools. It turns out that most computational science today is done on Linux or on some variation of Unix. Unix is an operating system that dates back to the late 60s. Linux is a variation of Unix. It was written from scratch, so it's not like it has a, let's say, a direct lineage to Unix, but it incorporates many of the same principles, and in particular, many of the programs that were originally written for Unix actually form the basis of what we do today on Linux as well. So I recognize that many of you today did not grow up with running things on Linux or on command lines in particular. So one of the things that sets apart how we interact with Linux is that, let's say, when you're a computational scientist, you have to deal with data oftentimes. And a lot of the things that we do happen on a command line simply because that is more efficient. So let's say oftentimes you have to filter things, you have to run different programs, you want to visualize something, you want to deal with files, and so on and so forth. So a lot of these sort of things under Linux are done on the command line. And of course, let's say if you have a Macintosh, for example, you would do the same thing as well. Macintosh basically has a Unix-like operating system, and it also has a command line where almost all of these tools that we use on Linux work as well. So I understand that most of you are not from, let's say, the Linux world. And when I teach my classes, I often find that, let's say, there's a learning curve involved in this, that you have to understand, let's say, how does a command line work a little bit, what are the tools, what are the programs that we often encounter under Linux. And so I would like to, let's say, give you a little bit of a background in Linux in the next few lectures if you're not familiar with this, because it provides the foundation for many, many of the other things that we're going to do in the subsequent lectures. So I call this lecture 2.9 because it sort of fits between, well, 2 and 3. And it is a very brief introduction to Linux, and the first part is basically about the command line. So if you grew up with Windows, or you grew up with using a Macintosh, let's say in the way most people do it, then you would deal with files, for example, through the file manager. And Linux, of course, has this too. So on my particular brand of Linux, there are many different brands of Linux. Let's say I use SUSE here, there's Ubuntu, there's Red Hat. Somewhere there's going to be a file manager. So in this case, it's under my brand of Linux, it's called Dolphin. So if I open this, like on every other operating system, you get to see, you know, a list of file systems and a list of folders. And let's say for me, in my folder P stands for programming. I use short names. So in P there is a folder for deal.II, and so on and so forth. So you see all of these things that are exactly the same as they are on many other operating systems. But what I really want to talk about, of course, is the command line. So the command line is an alternative way to deal with file systems and files and so on and so forth. And what I hope to show you is that there's a lot more flexibility if you know how to use the command line. And it turns out that for people who've been using this for a little while, it's also usually much faster. You can do a lot of things from the command line that are really awkward to do from a file manager. So if you want to run a command line, you typically do this in a program that is called a shell. And so a shell is the program that interprets the commands that you enter. And a shell is typically run in a terminal window. So a terminal window, you get this under Linux, for example, here from the Start menu. Under the KDE environment, that's one of the window environments on Linux. It's called console. So that's a terminal window, and in this terminal window runs a program that is called a shell, and in this case the shell is called bash. That's not particularly important, but so what it does is it interprets the commands that I'm going to enter. And just to show you an example, so if I say ls for list, then it's going to show me a directory listing. Okay. So let me just show you a few of the commands that you can enter on the command line. So ls is 1 if you wanted to provide a long listing, so not just the names of the files, but also the time when it was created and the size, for example, then you would use ls minus l. If you want to create a directory, you would call cd for, if you wanted to go into a directory, you would call cd for change directory. If you want to create a directory, you would say mkdir for make directory. If you want to remove a directory, you would say rmdir for remove directory. If you want to find out where you currently are, you would call pwd for print working directory. If you wanted to remove a file, you would say rm file. If you wanted to remove a whole directory and all of the subdirectories that are in there, you would do this recursively, and you would do this by saying rm minus r dir, for example. So one of the things that you already see here is that the commands under Linux or under Unix are typically very, very short. They're meant for people who are lazy, who want to not write too much, so the command is not called remove, it is simply called rm, for example. So you have to learn a few of these commands, but it turns out that actually with about a dozen commands, you basically do everything that you ever want to do on a shell. So there are, of course, other commands that you can call. So maybe you want to edit a file, and there are many different editors under Linux that you could call. So one is called Kate, another one is called kwrite. There's one that's called gedit. There's a simple one that's called nano. There's Emacs and VI and Eclipse and so on and so forth. So there's many different ways of editing files, and I'm going to show you some of those later on. So actually, maybe I'll call some of these commands and give you a little bit of an idea. So I showed you what happens when I say ls. Ls stands for list, so it just shows the current directory. If I say ls minus l, I get the same kind of files, right? You see the creation date, sometime in March and August 2012 and 2010. It turns out that I had to revive my old laptop for this particular lecture, and haven't used this laptop in years. So all of these dates are between 4 and 6 years old while I record this. So the file names, the creation date, in this case, these are all directories, so the size doesn't matter. And then there's something up front here. So the D says it's a directory. RWX means I, as the owner, am allowed to read, write, and execute. And then there are, let's say, if this was a multi-user system, the people who are in my group are allowed to read and to execute. So for directory, execute means to go into. And people who are not in my group, for everybody else, they are also allowed to read and execute. So let's say if I go into my directory where I store the deal.II directory, deal.II sources, for example, then now you get to actually see file sizes. So the license file, for example, has a size of 27,353 bytes. The README file has 1,758, and so on and so forth. Right? So that's what ls minus l shows you. So if I want to make a directory test, I say mkdir test. So there is now a test over here. I can go into this. There's, of course, nothing in there. I can go back out, which I would do with the ..dot command. So ..dot means the directory above the current one. And then I can delete this whole thing again if I want to. So other things that you can do. So let's say I wanted to edit the README file. So if I say kwrite README, okay, you know, I'll show you kwrite later. I'm using my favorite editor, Emacs. So it opens Emacs, it opens the file. You can see the contents of this. If I wanted to, I can edit it and do something useful or maybe not so useful with it. And one of the things that you see is that while I call Emacs, nothing is happening here on the command line, right? I cannot enter any command like ls or ls minus l. It doesn't output anything. And the reason for this is that all of the input that I enter here in my shell window is actually sent to Emacs. But Emacs doesn't care. Emacs wants to read from what I enter into this window. It doesn't care what comes in input into the shell window. So it looks like I have just blocked my shell window. And that's a little bit a nuisance sometimes, because maybe there's something else that you want to do at the same time. So let me show you how to deal with this. So I'm going to just close this file here. I'm going to get out of this. So I'm going to finish Emacs. Okay. So if I'm in this directory here, so what I want to do is I want to start Emacs in the background. And background means that it's not going to read any input from the shell, but it's going to immediately make the shell available again for other commands. So I'm saying Emacs readme.md, and then I put the ampersand at the end of this line. Okay, so I can still edit everything here, whatever I want to do. But at the same time, I have the shell window back to myself, and I can add other commands. So I could also, of course, open other copies of Emacs. Okay, so the ampersand really is a useful tool. Let's say I forgot, for whatever reason, to put the ampersand here. There's a way to recover. So I see my students always, in these cases, close Emacs, do something in the command line, and then start Emacs again. There's an easier way to do this. So I can hit Ctrl-Z, and Ctrl-Z does, so, okay, so I get multiple messages, and these are the two Emacs that I just closed, but the Ctrl-Z really caused this one here. So it says it stopped. And that means that the Emacs actually doesn't respond. It's in a suspended state. Okay, but I can use the command line here, for example. Now, the suspended state, of course, is a little bit annoying. But what I can do is I can retroactively put the Emacs into the background. And the command for this is called bg, background. Okay, so if I do this, then the Emacs here continues to run. Okay, I can edit here as I want, and I can use the command line. So even though I forgot to put the ampersand at the end of the Emacs line, with Ctrl-Z and background, I can have the same effect retroactively. So that's summarized on this slide here, where instead of Emacs, I wrote down gedit. Other things that you can do. So when I say something like gedit and a file name, so I want to edit this file, the first part of every command that I enter in a shell is always the name of a program. So in this case, gedit is the name of the program. And what the shell has to do is it has to figure out where is the executable, where is this program called gedit located? Well, it's not in my current directory. So if I look here, for example, let's say you remember I called Emacs. Emacs is not located in this directory. I can find out by issuing command which Emacs, where it is, and it turns out that Emacs can be found, the executable for Emacs can be found in the directory user bin Emacs. Okay, same thing for gedit. Let's see if I have this installed. Actually, I don't have gedit installed. So with which I can find out where that is. And so the question is, how does the shell actually find where Emacs is? And the way this works is that there is a concept that is called an environment variable. So an environment variable is essentially a list of variables, and I can see them by calling set. So if I scroll up a little bit here, at the top of this, there's a lot of stuff, a lot of variables that I set. So let's see how far up I need to go. Oh, maybe further than I have in this window. Okay, so I'm going to use a command that I will explain later. So if I say set, these are all of the environment variables. So in this case, so there's for example a variable ALSA config path, and it has a certain value, etc. Also pulse config. There's a variable that's called bash, and it has a value /bin/bash, and so on and so forth. There is another environment variable that is called path. And path contains, so it's the top one here, it contains a whole bunch of directories that are separated by a colon. So when you call a command like gedit myproc.cc or Emacs license, it's going to look for the Emacs executable in each one of these directories that are listed in the path environment. Now sometimes you don't want this. So sometimes, let's say you want to do something like this. So you want to call the step 3 executable. Let's say you're in the step 3 directory. So step 3 is one of the tutorial programs that we're going to discuss later on, the tutorial programs of deal.II. So you've compiled this, and it's located in the current directory. But the current directory is not one of those directories that are listed in the path environment variable. So in that case, you have to say // so you have to specify an explicit path to the executable. So dot refers to the current directory, just like dot corresponds to the directory above it. / is the separator between directories and files. Okay, so // means current directory in the executable is step 3. Similarly, if you wanted to call, let's say, a program Eclipse that you have installed yourself, so let's say it's in a directory home, Bangerth, bin, Eclipse, Kepler, bin, Eclipse, then if this path, home, Bangerth, bin, Eclipse, Kepler, bin, is not part of your, or if this directory is not part of your path environment variable, you have to specify the full path to that executable. And of course, that's sort of a time-consuming process if you had to do it every time. I mean, I would have to remember exactly what it is. So the approach that you would choose is you would add that path, because you use it frequently, you would add that directory to the path environment variable, and you would do this in the following way. So so I'm going to hit Ctrl-Shift-T, that opens another tab in my shell window. I'm going to say cd, which goes into my home directory. There is going to be a file that is called .bashrc, okay? And I'm going to go to the very bottom of this, and I would do something like this. So I already do something like this. So I'm saying export path equals, so that means set the path environment variable to, well, this directory here, home, Bangerth, bin, kdevelop 4.2 / bin, and then colon, and I'm going to add $path. That means the value of the current value of the path environment variable. So in essence, I'm going to set path to the directory of kdevelop plus all of the previous directories that were already in there. And then I'm going to save this in my bashrc. And in order for, so bashrc is a file that is executed at the, every time I start a shell window. So what I would need to do is I would need to close this and open a shell window again from scratch. Okay, so other things that you can do. Let me close this Emacs here. And for reasons I'm not quite clear about, my mouse has disappeared. Well, we can work around this. So console. Okay, so other things that you can do on a shell that's actually really useful. So when you run a program on the command line, it reads its input from the keyboard, unless you put the ampersand at the end, and it writes regular output to the shell window, and it writes error messages to the shell window as well. And these are called the standard in, standard out, and standard error streams. One of the things that's really useful is that you can oftentimes use the output of one program as the input for the next. And I should say that some programs, of course, do not care about input from the shell window, like the Emacs I showed you earlier, or maybe they don't write anything to the output, to the screen either. Emacs puts its output into a window, but not onto the shell. Okay, but for programs that do, then another example would be that ls, for example, doesn't read anything, but it writes a directory listing to the screen. But so one of the things that I can do is I can use the output of ls and use that as the input for the next program. So one of the very useful programs that where that makes sense is grep. Grep is a filter. So a filter, in essence, reads input and selects part of that as output again. So grep is one of those really old-timey programs that dates back to, I don't know, maybe the 70s. And I don't actually really remember what what grep stands for. I think it stood for something like Global Regular Expression Print. Doesn't really matter what that actually means, but in essence you can think of grep as something like this. So it reads every line and it outputs those lines for which that include the text that you give as argument to grep. So I had as argument VTK here. So if I say ls minus l and then this vertical pipe here, this bar, then grep VTK, that means, so the vertical bar means take the output of the thing on the left and use it as the input for the thing on the right. And that, in this case, means that grep reads all of the output from ls minus l. It's not going to appear on the screen. And it outputs only those lines that contain VTK. So let me show this to you. Maybe not with the exact same VTK files, but I looked into one of my directories last night, and so Aspect is one of the other projects that I work on. So if I say ls minus l, there's a whole bunch of files in this directory here. Some of those are files that have an ending that's called .prm. These are parameter files, so these are input files. And let's say I had many more files than just this. If I only wanted to output those that, or wanted to see only see those that are PRM files, I would say something like ls minus l, and then this vertical thing here, the number of spaces to the left and to the right don't matter. And so what I get to see are only the 1, 2, 3, 4, 5, 6, 7, 8 files that are .prms. So ls minus l still printed everything, but grep filtered out only those that I care about. And I can do many other things with these filters. So another filter, for example, is a program that is called WC, which originally stood for word count. So word count is a program that's going to count the number of lines, words, and characters that in the input stream. Maybe in this case, I don't care about the number of words and characters, but I care about how many lines there were in the output of the previous program. So when I put another vertical bar behind the grep and then say WC minus L, then that counts the number of lines. And so if I go back over here, right, so I had this command just outputs all of the PRMs, and if I put vertical bar WC minus L behind it, it's going to say 8. That's the number of lines that were given as input to WC. That was exactly the number of lines that grep output, which is exactly those number of lines from ls minus L that had the text PRM in it. So you see how, let's say, the combination of multiple programs on the command line allows us to do really complicated things pretty simply. So Unix has a philosophy where you have many little programs that do one task very well, and then you combine them with these pipes, with the vertical bar. And there are other things that you can do with the vertical bar. So I showed you how filters operate. Here would be another example. So let's say cat is a program that just takes a file name and outputs the contents of all of this, the content of this file. So let's say in this case it's one of the tutorial programs, step1.cc. I take the output of this and I put it into grep with argument 4. So that's going to output only those lines that contain the text 4. So for example, a for loop, but also if I had a comment in which I say something about the format of a line, that would also be something that grep filters, of course. And then the rest of it goes into WC minus L. So what I get as the output of this whole command line is the number of lines that contain 4 in step1.cc. Other things. So sometimes you don't want to just filter, but you want to transform. And I'm going to show you one of the really obscure programs that is called SED. So SED originally stood for Stream Editor. The point of SED is that it's really good at replacing things. So SED has a command, and that's how it's almost always used these days, that is called the s// command. S stands for substitute, and it's going to substitute whatever is between, actually it should be the s// command. It's going to substitute whatever is between the first set of slashes, and it's going to substitute that by whatever is between the second set of slashes. So if I substitute, let's say, so in my command here, I say cat step1.cc, so that's going to output the entire comment to the screen, but the output is redirected to SED, which is going to replace every occurrence of the string tr by tria. Okay, so it's a really useful tool if you want to globally replace something. And then I'm going to use the bigger than sign. And what that does is the output of SED, instead of being printed to the screen, it's going to be redirected into a file. So this command line is going to read the file step1.cc, replace every occurrence of the text tr by tria, and then going to put the whole rest into, put the whole thing with the replaced text into a file step1-mod.cc. So you may not have seen this, so I chose tr and tria because triangulations is something that we will talk about a lot in many of the remaining lectures. Another thing that you can do is there's a program that is called less. So less reads every line and shows you one page at a time and allows you to scroll up and down. That too is something that I should show you. So let's say if I look at the blankenbach.prm file, actually I want to write it like this, so cat blankenbach less, then it shows me one, so instead of printing the whole thing and running all the way through the end, it shows me one page at a time. It allows me with the key, with the up and down keys to scroll up and down. So that's something that we use very frequently if there's a lot of output, so that we can scroll up and down and search for things. So I showed this to you with the pipe version. I could also write this like this. So less takes an argument, and I could have written it as less and the file name. So less is one of the really useful commands. I just wanted to show it to you with the vertical bar. Other things. So when you want to know something about programs on Unix or Linux, so oftentimes you forgot exactly what does this program do, what is the argument, should it be ls minus little l or ls minus capital L. Every Unix or Linux tool has something that is called a man page. A man page is short for manual, and you can see these man pages by entering the command man grep, for example, or man set, or man sort, or man head and tail, for example. So these are all commands for which you can find a help page. So let's say sorting is something that's a transforming filter if you want to. So I could do something like this. That doesn't make any sense, of course, here. I could say cat blankenbach, and then I could say sort this, and it's going to sort all of the lines in alphabetical order, which clearly makes no sense here, but I can. If I want to find out what kind of arguments sort takes, I would say man sort, and so in this case there are multiple sort commands. I'm just going to say enter, so it says at the top it's sort lines of text files, and then it shows me all of the possible options that I can use for this. So one of the things that I often use, for example, is sort minus n, which doesn't sort lines by, let's say, alphabetical order, but interprets it in terms of numbers. So it's one of the frequent things we do. So man is a really useful command because it allows you to learn about things. And I think the sort of commands that would be useful for you to learn something about are certainly grep, set, sort. Head shows the first few lines, tail shows the last few lines of a file, and so on and so forth. So I hope you got sort of a sense of how the command line works. So the command line at first seems a little bit clunky. I mean, you'd think that today we've moved past that stage where we are better off with a graphical user interface where I can use the mouse to move things around. Well, it turns out that it's actually really, really useful to use this, because the command line allows us to connect files through input and output with this pipe thing. So that allows us to filter through many stages, and oftentimes if you have to process a lot of data, that's a really, really useful tool that's very difficult to emulate with a graphical user interface. And learning the basics of the command line really is something that, let's say, makes you more productive, where you have a better understanding of how all of these sort of things work. So there's a little bit of an effort involved in learning this, but it's absolutely worth it. And I hope you saw, let's say, how I interact with this, and that gives you a little bit of an indication of what can be done.